as long as I can remember. I think as long as this existed.
I think so. Yes.
It's been a long time since they've been part of it. I do want to actually do a couple of goodies that we have over there and a couple of t-shirts and some pens that you can take with you if you want. Just grab one if you want. We created these t-shirts for the RAF Celebration Day. It would be sad if we have to carry them home. So I don't know. This looks more like a warm air balloon or something, but so Tom, you'll take it away.
Yes. So we've got an introduction from Rick about graph algorithms. I'm going to show you how I tried to implement one at a startup where I used to do some consultancy work. And during that phase where we're investigating how to use a graph, I was searching for a graph algorithm. It wasn't there, so I was one of the contributors to the first APOC library for strongly connected components. Now they've taken my implementation and changed it all around, so it's not mine anymore currently. But I was one of the early adopters of these APOC libraries. So what I'm going to talk about is the company was trying to provide a solution for duplication of data. So we all know that in enterprises, users are spread around our systems. We have users in ERP systems, we have users in online systems, we have all users spread around. And at some certain point, somebody comes and says to you, okay, but who are my unique users? And in some systems you have an email, in some systems you have other data, your name is not spelled correctly and things like that. And that's what that company wanted to solve. Now, there was typically already some algorithms that do these things, but we identified some special cases where graphs can help to do these things. Because if you take the deduplication, there are two problems. I'm going to explain not two problems, so there's two things that you need to know. So there is the use of similarity functions. So if your name is Tom, but sometimes you spell it Thomas, you use these similarity functions to detect that maybe it's the same name that is being used. That's one part of a deduplication algorithm. And then the other part is you need to make combinations of pairs. So you have records on this side, you have to compare to the other one. The problem there is that the amount of data grows, the amount of pairs is also going to grow a lot. So in traditional approaches, the way to solve that is to create buckets. So to make your data, partition it a little bit smaller, so that you're only going to make pairwise comparisons with 100 records that maybe live in the same street, or they start with the same name. So they create all these kind of buckets so that you can condense those kind of combinations into. Now, we noticed that these things like similarity functions and these buckets are things that are native to a graph. In a graph, the bucket is kind of the starting point of your iteration, and you go around and you